Hey, welcome back to day 2. We are going to continue to talk about matter and energy in an ecosystem. Now, yesterday, you'll remember we were down here and we were talking about matter. Today, we're going to really focus on energy. So, let's refresh by remembering that energy is the power to move, grow, make heat, or reproduce. So, unlike matter, which is stuff, which is the things that have mass or that take up space, energy does not have mass. And energy does not take up space. I can't weigh energy and I can't stuff it into a bag and fill the bag with energy and see it expand. So, energy is different. When we talk about energy, we are really talking about the power to move. So, that's that kinetic energy that you learned about in 4th grade. Grow, where you get bigger and you keep adding more to the organism, or like you can have a baby grow up and get bigger, or a small plant grow like our bean and our wheat seeds. Energy also is allowing animals and plants to give off heat. Right now, you are making heat and giving it off. If you sit really close to someone, you might feel like, oh, they're making it too hot in here. I can feel them giving off heat. And energy also lets organisms reproduce, whether that means making seeds, laying eggs, or giving birth to live young. If something is moving, growing, giving off heat, or reproducing, it is using energy. So let's look at where the energy in our ecosystems and our food webs comes from and how it moves through the system. All right, and we're going to start with our producers, our plants. And we learned that at the very beginning, plants are getting all their energy from the sun, that star way out there in our solar system. It is where all the energy that the producers are using is coming from. And we learned that they take that energy in, they absorb it through their leaves, and they use it to power themselves. They are literally solar powered. So plants take in light energy from the sun, and then plants lose some of their energy. So I'm going to circle this. They lose energy as heat. Oops. They also use up some of that energy to grow. As a plant grows, that takes energy. Once that energy is used up, it's not there for the plant anymore. The plant also reproduces. Like we learned that they make seeds. Your bean seeds took energy to make, the wheat seeds took energy to make, and they actually store energy in those seeds. So the plant is using up some of that energy, and then it's storing it. It stores it in its leaves, in its roots, in its seeds, basically in all of its tissues and all the parts of it. Flowers have energy, the stem, the bark, all of that has energy. And anyone who's ever had a campfire, you've used some of that stored energy. You've got it burning, and then it gives off heat and light. That's all energy the plant has stored that we can use. So what about consumers? How do consumers get their energy? Well, they take in food energy by eating producers and sometimes by eating other consumers. So plants are storing the sun energy, but consumers are getting that energy when they eat plants and other animals. So when you eat something, because you also are a consumer, you are getting the energy from whatever you ate. So consumers are getting rid of some of that energy. Some of it gets given off as heat. Some of it you use to move and to grow and to reproduce. So like this elephant, it's taking energy just to move its body around. It's creating heat energy. It's growing. Even if you're not growing bigger, your body's constantly replacing its cells. So as the elephant's cells grow old and need to be replaced, it's using energy to grow new cells. And then when it has little baby elephants, it's using energy to reproduce. The elephant then stores this energy. Some of it gets stored in its body, so its body also contains energy. So later, when it gets eaten by something else, that other thing will get the energy it's stored. So maybe not a full-grown elephant, but we talked yesterday about how a baby elephant could get attacked by a lion and eaten, and lots of other consumers get eaten. We learned that when we did our food webs where we had snakes that got eaten by hawks, or trying to think other small, like a squirrel might get eaten by a coyote. So when it gets eaten by something else, its stored energy gets given to that other consumer. It also gives off energy in its waste. Its poop even contains energy. There are some places in the world where people burn dried animal waste for energy. In fact, some of you may have learned that while you were doing your Oregon Trail unit, and you learned how they would collect dried cow pats, which is buffalo poop or cow poop. They would pick up the buffalo chips, they called it sometimes, and burn those for energy because they still contained energy. Finally, we have the decomposers. So the decomposers are getting energy from the waste that it breaks down. So when it breaks down like the poop, it gets energy. It also gets energy from dead animals. Remember, we talked about how consumers store energy in their tissues. And it gets energy from the plant material it breaks down. So they're getting energy from poop, dead plants, and dead animals. And they use that energy. They give off a little bit of heat. You might not be able to feel it by touching them, but we have evidence that they give off a little bit of heat. They use the energy to grow, and they also use the energy to reproduce. When we saw the mushrooms spreading their tendrils through those leaves in our Mystery Science video, and then eventually sending up the big mushroom, all of that takes energy to do. It also takes energy for the bacteria to reproduce into new bacteria, and the mold to send off spores. Here's the big change though. Look here, no more energy left. Decomposers use and consume and work their way through all that matter, and eventually there's no energy left. Now with our matter, we learned that they leave nutrients behind, they give off carbon dioxide, there's still matter moving around, but when the decomposers are done with it, there is no more energy left. Let's see what that looks like in a great big food web. So we've got our producer down here. It's taking in energy from the sun, and it's storing that energy for others to eat. Then along comes my consumer, right here, this grasshopper. He eats other organisms, and he gives off waste, and he stores energy in his body. The bluebird eats him and gets that energy. The snake eats him and gets that energy. The owl eats the snake and gets that energy. And all of them are also, we know that they poop, and they're giving off energy that the decomposers are breaking down. I'm going to write poop. How often do you get to write that in class? Let me write that correctly. So we know that that's happening. And then eventually this owl, because we talked about it, he's the apex predator. Nothing's going to come eat him while he's alive, but eventually he'll die, and his dead body will be broken down by the decomposers. So the sun has tons of energy. It gives some to the grass. The grass uses some and passes some along. The grasshopper uses some and passes some along. The bluebird uses some and passes it along. Everybody's passing it along. And as they're using it, they lose a little bit of the energy. Some of it gets used up, but some of it gets passed along. So I'm going to draw extra arrows here. The grass is getting lots of energy. It's giving lots of energy, but the grasshopper is going to use up some of it. These guys are all going to use up some of it. By the time it gets to the decomposers, there's a lot less energy there. And the decomposers are going to break down those dead organisms and their waste, and they're going to use up all of the energy. There is no energy arrow going from my decomposer to the producer. All I have is this big, nope, you shall not pass. The decomposers are not giving energy to the producers. They used up what little was left, and the energy is used up. The sun's going to keep giving energy, so our world keeps getting new energy, but it doesn't cycle around like it does with matter. Next time you see me, we're going to discuss how these two cycles are different so we can really understand them together. See you next time.